The title of the project is Accident Prevention Using IR Sensor. Okay, coming to the contents which I'm going to explain is abstract, objectives, methodology, list of hardware software used, results and discussion, societal relevance, conclusion and future scope. Coming to the abstract, in developing countries, accident is a major cause of death. There are many dangerous roads in the world, like mountain roads, narrow curved roads, T roads. In this some mountain roads will be very narrow and they contain so many curves. For example, Devimari Ghat in Karnataka, Kinnu Road in Himachal Pradesh, and so on. Even India is a country with maximum number of railway routes. For example, Delhi Kanpur segment, Ahmedabad Surat segment, the Vishakhapatnam Vijayawada segment, where maximum deaths has been recorded. In some of the curved roads, the other end of the curved road cannot be seen by the driver because of the obstacles like trees or rocks, etc., present in the middle. In this type of roads, thousands of people die because of careless or presence of unexpected obstacles. According to Million Death Study, about 2.3 million people die in India per year. In that, 157,000 is because of road accidents. That is about 377 people per day. In that, 3.7% because of failed to hit the road. The problem in this curved road is drivers can't able to see the vehicle or obstacles coming from other end of the curve. If the vehicle is in very speed, then it is difficult to control and there are chances of falling to cliff. To reduce next, to reduce the risk of accidents on these roads, a sensor-based system is used. Objectives. The major reason of death on curved roads is due to other end of the curved road cannot be seen by the driver. To alert the driver about the other vehicle coming from the other end, a sensor is placed which helps in alerting the driver on both the sides. You can see in the picture as shown. Railway road accidents are due to carelessness of the gatekeeper. Sensors are placed which help in automatic closing and opening of the railway gate operation. And coming to the methodology, this is a circuit diagram of U-shaped road which consists of a battery of 9 volt. An voltage of 9 volt battery is given to a 7805 regulator. This 7805 regulator brings down the voltage to 5 volt from 9 volt. And the main component which you are using is IR sensor. The IR sensor mainly consists of an op-amp. The non-inverting is supplied with 5 volt. This 5 volt is considered as the reference voltage. When IR sensor does not receive a signal, that is, if no vehicle is detected in the range, inverting input of op-amp goes higher than the non-inverting input, and hence the output of the op-amp goes low. If the output of the op-amp goes low, the LED light, that is green LED, becomes forward biased and it turns on, and the buzzer becomes reverse biased and will not beep. When IR sensor receives a signal, that is if any vehicle or vehicles are detected within the range, the non-inverting terminal of op-amp goes high and hence output of op-amp also goes high. If the output of op-amp goes high, the LED light, that is red LED, becomes forward biased and it turns on and buzzer starts beeping, indicating the vehicles coming from the other side to stop. And next is nothing but the block diagram of railroad. This is the block diagram of railroad. The sensor circuit is connected to the microcontroller where the power supply is given. The microcontroller in turn is connected to the motor driver which controls the automatic closing and opening of the gate through motor. And coming to its working part, railway being the cheapest mode of transmission, it is preferred over all the other means. When we go through the daily news, we come across many railway accidents occurring at unmanned railway crossing. This is mainly due to the carelessness in manual operation or lack of human resource. We in this project have come up with a solution for the same. Using simple electronic components, we have tried to automatic control of railway gates. As the train approaches the railway crossing from either side, the sensor placed at a certain distance from the gate detects the approaching train. and accordingly controls the operation of the gate. Also, an indicator light had been provided to alert the motorist about the approaching train. The two IR sensors are placed at the left and right side of the railway gate. The distance between two IR sensors is dependent on the length of the train. In general, we have to consider the longest train in that route, and if the sensor detects the arrival of the train, the microcontroller starts the motor with the help of the motor driver in order to close the gate. The gate remains closed as the train passes the crossing. When the train crosses the gate and reaches the second sensor, it detects the train and microcontroller will open the gate. This is the working of railroads. And coming to the list of components which are used are nothing but IR sensor, servo motor, NPN transistor, 8051 microcontroller, 7805 regulator, 8089C51 microcontroller, LEDs, battery and buzzer. Coming to the software, Arduino UNO has been used as a software. And results and discussion. It avoids accidents in curved roads, mountain roads, hill roads, and railway roads. Saves hundreds of lives, easily implementable to the existing roads, fully automated, that is, no person is required to operate. And even installation cost is also very less. This system will alert the driver about the vehicle coming from the other side of the curved road and hence help to prevent accidents efficiently. Human intervention at level crossings can be removed with the help of this project. Many railway level crossing accidents can be prevented as well. And coming to the societal relevance, it avoids accidents in curved roads, mountain roads, and hilly roads. It saves thousands of lives, easily implementable to the existing roads, and even installation cost is also very less. An automatic railway gate control is implemented with a very simple hardware and easily controllable, and human intervention at level crossing can be removed with the help of this project, and many railway level crossing accidents can be prevented. And coming to the conclusion, the purpose of this project is to decrease the number of accidents in curved roads and railways. This is done by alerting the driver by means of LED light which glows when the vehicle comes from the other side of the curved road. The vehicle is detected by the help of IR sensor which is interfaced with a buzzer. When it comes to railroads, automatic gate control system offer an effective way to reduce occurrence of railway accidents. By this, we can save hundreds of lives in curved roads and railways. And coming to the future work, arrangements to protect the sensor from being damaged in critical places. It decreases the size of unit so that it occupies a small place and easily kept in narrow roads. Implementing the system to detect number of vehicles and velocity of vehicle. Thank you.